So this is the worked answer to Unit 8 test question 2. In this question we have a cyclist with a mass of 80 kilograms. It's travelling with a speed of 80 meters per second. The cyclist stops pedalling and comes to rest. So he just slows down naturally, he doesn't brake, and the only thing causing him to slow down is the friction with the road, air resistance and things like that. So we're told the resistive forces are totaling 120 newtons. We're asked to find three things. How long it takes a cyclist to stop, the distance the cycle goes before it stops, and a limitation in the model. So, finding how long it takes the cyclist to stop. We know his current speed of 18, so it feels like it should be a Suvat equation. So we know his current speed of 18, we know his final speed of 0. We don't know the distance travelled, and that is what I'm trying to find. And in part B, we don't know how long it is either. So I'm trying to find S and I'm trying to find T. To do that, however, I need another variable. So I need the acceleration. So I'm going to draw a force diagram for our cyclist. So we have 80 kg, and the only force acting upon this is the 120. The resultant, by definition, is the result of all the forces acting on it. The resultant must be 120 because that is the only force. So using F equals ma, I can get 120 equals 80a, so 1.5 equals a. I need to be careful here because it's accelerating in that direction, or decelerating if you like. I also need to realise that it's actually travelling in this direction. So I'm going to add the 18 and the 1.5 to my diagram. But when it goes in the Suvat equation, I need to be careful that I put the acceleration as minus 1.5. To find the time, I'm going to use V equals U plus AT. So V is 0, so 0 equals 18 plus minus 1.5 times by T. So I end up with minus 18 over minus 1.5 equals T. So 12 is equal to T. I'm then asked to find the distance. And I could now use that 12 to find the distance. My issue would be that if this 12 is incorrect, my distance is going to become correct. So I'm going to choose a formula that doesn't use T, but does use SU, V and A. So I'm going to use V squared equals U squared plus 2AS. I could substitute straight into this and start manipulating it. I find it easier to manipulate it with algebra. So I'm going to change this to V squared minus U squared over 2A. And that's what S is equal to. And now I'm going to substitute into this. So 0 squared minus 18 squared over 2 lots of minus 1.5 is equal to S. By typing this into a calculator, I'm going to get a distance of 108. Similarly, just showing that it could have been done using the T, we know that distance equals time times average speed. So that equals 12 times 9, which again equals 108. Clearly, this method is easier, but like I said, it does rely on the fact that you got T correct. The final part of the question is to do with the modelling assumptions and asking you about the limitation of the model. When I first read the question, I came up with air resistance, but then arguably air resistance is included in this resistive force. Then I thought about the surface, and we have assumed the surface is completely flat. From driving on roads and looking around the environment, we can see generally roads undulate and go up and go down. I also said that we wouldn't be able to exactly get 18 meters per second because it's a continuous number. To get exactly 18 isn't going to be possible. Similarly, the same argument could be made about the 80 kilograms. The other thing I thought about, it says about the cyclist of the mass. It's completely ignored the fact the cyclist must be on a bike. So I said that we could have included the mass of the bike when we was using F equals ma. I was then able to look at the mark scheme, and the mark scheme says the cyclist is not a particle, which doesn't really matter because the particle is included in resistant forces, but this idea, resistive forces, are unlikely to be constant.